Welcome back. Today we're going to talk about how to differentiate logarithmic functions. Now, these ones are not intuitive, and you really just gotta do practice until you get one. And important for this is that in order to understand this video, you must know the laws of simplifying logarithms, and you must know them well. We will not be going over the mechanics of simplifying the logs in this video. So if you're uncertain about that, please go back and watch my video about simplifying logarithms and then come back to this one. So, if you want to differentiate a function that looks like this or this, the ln of a function, or the log anything of a function, the formulas are not intuitive. But who knows, maybe they are intuitive to you, and in that case, you are better at math than me and probably overall smarter. Congratulations. Alright, but for the rest of us, the only formula that you really need to memorize is the one down here. Because you'll notice that in the natural logarithm's derivative, you're missing the lnb. But the reason why is because ln is log base e, and ln of e simplifies to 1 and goes away. So, it's always a good idea, sorry I'm fiddling to try to get the contrast right again. It's always a good idea to remember this one. That's the one that I'll be writing at the top of the board while I do my examples. Darn you, sunlight! Yeah, I mean, I don't have fancy camera equipment. I'm doing this next to my window so you can all see. Alrighty, let's get down to business, yeah? Alright, let's start with some basic ones that don't require any logarithmic simplification. With this one, you can see that the inside is 3x plus 1. Which means that the derivative will be the derivative of the inside, which is just 3, over the inside of the function itself, and you may notice that it's a natural logarithm. It's log base e, so there doesn't need to be an ln of e there because it simplifies to 1. Now, because this part is fairly easy and you guys should know how to do derivatives, I'm going to let you try these two on your own. You can pause it and give it a second now. Alright, now I'm just going to write them down for you. Alright, so hopefully it's what you got, and each time you'll see that the derivative of the inside goes to the top. Keeping it note that the 12 turns into a 0, so it is negative. And the bottom, you put the original function plus ln of the log base, keeping in mind that the basic log right here is log 10, so it turns into ln 10, just like here, turns into ln 7. That seems easy, right? Well, when you combine it with logarithmic simplification, as will be in most problems, let's see some of those, huh? Okay, and something that I want to let you guys know is that this is hard, but you can do it, because I'm actually not that good at math. I'm an artist by trade and training, and the way that I was able to eventually become a teaching assistant in a college is because I met the best teacher ever. Her name is Liz Stanwyck. If you're at UMBC, take Liz Stanwyck's classes. She is hands down the best teacher I've ever known. But anyways, so an important thing to remember when you get to a function like this is while you technically could do it this way, you know, I've yet to see anybody do it successfully, especially more than once, especially if you're the kind of person who's watching my video right now to learn. So what you have to do is you must factor and use the laws of logarithms to completely simplify a logarithmic function before taking its derivative. Every single time. Let me show you what I mean. Alright, now that you have completely factored and simplified it into this form, you'll notice that it's a lot easier to apply the laws of a derivative of logarithms. So, let me show you how to do. The first step is to just apply the formula to each piece individually, without losing track of that 3, because it still applies. There you go. You just take the derivative of the 2 parts separately. But uh-oh, that's not a final answer, because you are expected to do basic cross multiplication and simplification to find your final answer. But all of you know how to do that, and I will walk through it. Well, actually, I'll just do it and then I'll, explain it, I guess. Okay, so as you can see, it's just a matter of basic cross multiplication to get to your final answer. 2 things are worth noting here. The first is that you can leave the denominator factored. The second is that you only have to cross multiply if there are 2 or fewer pieces to the function. If it was to be, say, 3 over x minus 1 over x plus 7 plus 2 over blah, 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 if there are 3 pieces, you do not have to cross multiply. However, if there are 2 pieces, you do have to cross multiply. Let's do another example like this one. This one is a better example of why you need to use your logarithm laws to factor and simplify completely before doing any differentiation. So, the first step, as before, is to logarithmically factor and simplify. And while factoring isn't necessary by the book, it makes it a lot easier. Just believe me, if you can factor while you logarithmically simplify, you want to do that. Alright, so this is what it looks like when it's factored and simplified fully, which gives you a nice, easy formula, with of course that 1/3 in front. So there's a couple formulas to plug into your derivatives of logarithms function. Alright, what you'll notice is, again, this is not a complete answer. You have to simplify it because there are 2 pieces that to cross multiply. So in this case, what we're going to do is you can leave the 3 outside because it's a common denominator, and you just have to cross multiply this with this. Alrighty. Sorry, my dog was fussing. All you have to do is cross multiply the different pieces on the denominator, and then you simplify them together, leaving the denominator factored, and you get negative 11 over 3 times 2x plus 1 times 5x minus 3. And this is the proper form for your derivative for this function. Let's do one more. Or, 2 more. Alright, so here's problem 5. It's one where, again, apply your logarithm rules. And oops, let me make it really clear that the power of 2 is with that x and not with the 1/2. Alright, so the first thing you gotta do is logarithmically factor and simplify as far as you can to make it possible to plug into this formula up here. Now that you've gotten to this point, all you gotta do is, again, apply the function to either parts of this logarithm, keeping in mind that log without a number next to it is what we call log base 10. Alright, what you'll notice is that there's a 16x up here, and there's a 2 down here. So I went ahead and simplified it down into 8x over the denominator. And here, you'll notice that there are 2 parts again, so you do have to cross multiply part 1, part 2. Time to cross multiply it. Alright, and that takes us to a final answer. You might have noticed that video part was a little bit stuttery. And the reason why is because I noticed that I made a mistake in the problem I wrote out before I made this. And that's an important lesson, that you can have been working as a TA or LA for more than a year, like 2 years now, and you can still make mistakes, and that's okay. Let's do one more. Alright, here's a situation where factoring comes in handy. With a lot of logarithm problems that you'll see, the factoring has already been done for you. But as you can see, you can pull out 3 and you can pull out x squared from what's on the inside here, and I promise that will make your work easier. But you can do that through the logarithmic simplification. Alright, when you get to this part, now all you have to do, excuse me, now all you have to do is plug it into the formula. But keep in mind, the derivative of 3 as a constant is 0. Alrighty, so after you apply the laws, you get something that looks, well, you get this. Noting, of course, that I simplified the 9x squared and the 6 to make it into just 3x squared over 2. You have more than 2 differences. You have the x, you have the 3, you have the 2, and you have 3x squared minus 1. Which means that you do not have to simplify further, and you don't have to cross multiply. Except you can tidy it up a little bit, so your final answer should look like this. Okay guys, that has been 43 minutes of derivatives of logarithms. If you have any questions and you're one of my students, please send me an email and I'll be happy to answer questions. And of course, as always, have a great day. Thank you.